In this video, we're going to solve quadratic equations by using the quadratic formula.
So we currently know 3 strategies for solving a quadratic. The first one that we know of is we know factoring. So we can try to use the factoring strategy. Typically when students see this, they notice that this is a trinomial. So they'll notice, okay, A is 1, B is 8, and C is 4. So they'll multiply A times C, and they'll know that they need to find 2 numbers that, multiply to 4, and then add to that middle number, that B value of 8. And when they start thinking of those, they realize they can't find one. And as a result, because of this, what that's telling us is that this isn't a nicely solvable problem, and as a result, factoring just doesn't work. Then from here, students will try to use the square root strategy. And the problem here is that if we try to solve this using square roots, we have 2 x values. The key to using the square root strategy is we get the squared piece alone, we use the square root function, and then we solve for a single x by itself. Well, the problem here is if we can't get a single x alone, we can't use this strategy. So the problem here is that we can't combine that x squared and 8x in any way. So as a result, square roots is out. Now, the other strategy that we know is completing the square. And this one still works here. But we always like to have options. Sometimes people find different strategies more difficult than others. And while completing the square is a valid strategy here, we're going to explore a different strategy. So we have, as you can see, currently 3 different strategies that we can use to solve quadratics. And what we're going to do today is we're going to add in our 4th strategy, which is using the quadratic formula.
So on the screen here, you're going to see the quadratic formula. And within the quadratic formula, you see values of A, B, and C. And these values of A, B, and C actually correspond with the values of A, B, and C that we used back when we actually factored out a trinomial and we used the ABC method. So A is our coefficient of x squared, B is our coefficient of x, and C is our constant value. So we have to rewrite our quadratic so that it is set equal to 0 in descending order so that we can easily identify A, B, and C. Now, this formula is commonly read as x equals, and then it says negative b. You can really call this opposite b because it's going to have the opposite sign of b, but it's x is equal to negative b plus or minus the square root, you can see that here, of b squared minus 4ac all over, or all divided by, you can see that there, 2 times a. So that's our quadratic formula. Now, if you want some help memorizing this, I would go to the YouTube video shown below. This has a song that goes to the tune of Pop Goes the Weasel. And it really will allow you to memorize this equation pretty easily. But again, it is the x value that goes with that equation. X is equal to negative b plus or minus the square root of b squared minus 4 times a times c, all over or all divided by 2 times a. So let's dive in and use this equation to help us solve a quadratic. So here we can see we have a quadratic because we have a highest x term of x squared, so we have a degree of 2. And we can see that we already have this written in a way that we can easily use the quadratic formula. So we have 0 on one side of the equation, we have all of the terms grouped together on the other, and we have them in descending order. So I can see that my a value is equal to 3 because that's the coefficient of x squared. I can see that my b value is 5 because that's my coefficient of x. And I can then see that my constant value, my c value, is a negative 9. So I start off by identifying the a, b, and c values that go into this equation over here, the quadratic formula. Then from here, my next step is I want to then substitute all of these values into my equation. So I always say my first step is to substitute. And so we start off doing that. We take x is equal to negative, I put my b value in, which is 5, plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a, which is 3. Now, a couple of things you're going to notice here. First is that I utilize parentheses every time I substitute in a value. Second, I'm also going to go in and utilize keep change underneath this square root with this subtraction, because that will prevent me from making any errors. So the first thing I do is I substitute all of the values for a, b, and c into my equation, which is the quadratic formula. Then from here, my second step is I simplify, but I specifically focus on simplifying the square root portion, because that's really the trickiest part of this entire formula. So I'm going to focus on right here. So that portion right here, I'm just going to focus on simplifying. So here I have 5 squared, and then I have plus a negative 4 times 3 times negative 9. And here, using the order of operations, I would do the squared first, which is 25. Then I do plus, then I have negative 4 times 3, which is a negative 12. And negative 12 times negative 9 is 108. And those two items added together equal 133. So I simplify that piece underneath the square root. So now I'm just going to rewrite this as x is equal to negative 5 plus or minus the square root of 133 divided by 2 times 3, I can see, which is 6. Then from here, if you want to go one step further, I actually like to evaluate that square root, so I know what that square root actually has a value of. So if I take the square root of 133, I end up with negative 5 plus or minus the square root of 133 is the number 11.53, all divided by 6. So that's my second step, is I simplify the portion that contains the square root. Then at this point, I take this plus or minus into account. And what I do here is I split that plus or minus. Because what that plus or minus is really saying is there are two situations here. The first situation is we have negative 5 plus 11.53, all divided by 6. And the second situation is I have negative 5 minus 11.53, all divided by 6. So I now split it and I take each situation into account. And then all I need to do is solve each miniature fraction. So I then need to take into account that I have little miniature parentheses up here. And then I start with the first problem and I add the two numbers in the numerator together. So I have negative 5 plus 11.53, which is 6.53, then divided by 6, which equals about 1.09. And then the second problem over here, I take negative 5 minus 11.53, which becomes negative 16.53 in my numerator, divided by 6, which if I divide that out is about negative 2.755. So here I have two possible values for x that will make this original equation true. I have x is equal to a positive 1.09, and I have x is equal to a negative 2.755. Alright, so example 2 here, you can see that this isn't quite set up to be ready to use the quadratic formula. So the first step we need to take is we need to rewrite this just like we did when we were factoring so that we can actually utilize the quadratic formula. So we need to add 13x to each side. And then we need to make sure that we write this entire equation on the left-hand side in descending order. So we're going to take 2x squared plus 13x, I'm going to do plus a negative 10, is equal to 0. So this is now rewritten into descending order. And now that we've got this rewritten and ready for the quadratic formula, we can start by finding our values for a, b, and c. So if we look at our equation, we find that the a value is equal to 2, the b value is equal to 13, and my c value is equal to negative 10. So our first step is to find a, b, and c. Then after this, we have our three s's, and our first is to substitute those values for a, b, and c into the quadratic formula. So we're going to substitute those values in there. So again, we're going to utilize this equation up here. So we have x is equal to a negative, using parentheses, b, plus or minus the square root of b squared minus 4 times a times c, which is negative 10, and then I'm going to use keep, change there, all divided by 2 times a, which is 2. So our first step here is to substitute. Then after this, we simplify, so our second s is we simplify the part underneath the square root. So here I'm going to focus on just this portion here. So I have 13 squared plus a negative 4 times 2 times a negative 10. So we start off with 13 squared, which is 169, plus I then have negative 4 times 2, which is negative 8, times a negative 10, which is 80. And we add those two values together, and we get a value of 249 underneath our square root. So now I can rewrite this as x is equal to negative 13 plus or minus the square root of 249, all divided by 4. And then because I now know what value is under the square root, I can evaluate the square root of 249, and I can write this as negative 13 plus or minus 15.78, all divided by 4. Now that I've got that simplified, I can focus on this plus or minus piece. And remember, this is simply communicating that we have two situations. We have a situation where we have negative 13 plus 15.78, all divided by 4. And then I have a situation where I have negative 13 minus 15.78, all divided by 4. So this is my split portion of solving the quadratic formula. So for this first one, remember, we always do our numerators first because there's really parentheses around that. So we have negative 13 plus 15.78, which becomes about 2.78, then divided by 4, which gives me 0.695. And then the second one, I have negative 13 minus 15.78, which is about negative 28.78, all divided by 4, which is about negative 7.195. So at this point, I have two possible values for x that will make this original equation true. I have x is equal to 0.695 and x is equal to a negative 7.195. And third and final example here. So again, we start off the quadratic formula by getting all of the terms together on one side of the equation. So we're going to add 7 to each side. And then from here, we want to make sure we write them in descending order. So we have 2x squared, then I'm going to write plus, this is really a negative 1x, plus 7 is equal to 0. So I've written this in descending order with all of my terms on one side and 0 on another. And then in order to use the quadratic formula, I need to identify my values for A, B, and C. So I see A has a value of 2, B has a value of -1, and C has a value of 7. So from here, I'm going to go through and I'm going to substitute in those values for A, B, and C into the quadratic formula. So I have x is equal to a -1, so negative b, plus or minus the square root of b squared, which in this case is -1 in parentheses squared. Then I'm going to do plus a -4 times 2, which is a, times c, which is 7, all divided by 2 times a, which in this case is 2 times 2. Now what I want you to notice here with this negative b is here you have minus a -1, which we know if we have minus a negative, this can really be rewritten as a positive 1. So kind of keep that in mind. Be on the lookout for those types of situations. So now that we've substituted, we're going to simplify that portion that is underneath the square root. So we're going to focus on this piece right here. So here I have -1 squared plus a -4 times 2 times 7. While -1 squared, be careful with this. I know that that is a positive 1. So make sure you utilize those parentheses so your calculator doesn't confuse you and make a mistake. And then I have plus -4 times 2, which is -8, -8 times 7, which is a -56. So that value underneath the square root becomes a -55. So what we really have here is we have x is equal to a positive 1 plus or minus the square root of a -55, all divided by 2 times 2, which is 4. So then I go to my calculator and I want to simplify that square root piece, and I go to take my square root of -55, and what you should be seeing as you take the square root of -55 is you should be seeing that you're getting an error. We know that we can't take the square root of a negative number because we know that nothing squared is going to produce that -55. So if you're solving along and you get to this point in the simplifying process where you notice you have a negative underneath the square root and there's an error, what this is actually telling you is this is telling you that there is no possible value for x that will actually make that equation true. So just like we saw with previous strategies, the quadratic formula will also be able to easily identify if we have a no solution situation. So if you get to this point and you figure out that you have a negative underneath the square root and you know that that is going to not be able to find you a value for x that makes the equation true, you can simply stop and write no solution.